Okay, so we are looking at examples of where we're trying to find a probability or a percentage, either way, pretty much means the same thing, for a particular range of values. So the way we do this is start by writing the problem in P of X notation. So you're spelling out exactly what it is you're trying to find. And then you can either let the calculator or calculator app or whatever do all the work, or you can do it yourself by converting your X numbers to Z scores using the formula Z equals X minus mu over sigma, and then writing the problem in P of Z notation, and that turns it into the kind of thing we were doing in the last section. So, for example, suppose there's some test, like an IQ test, for which the scores are normally distributed, and suppose the mean is 100 and the standard deviation is 15. What percentage of all the scores are between 100 and 120? Or, equivalently, what's the probability that a randomly selected person will have a score between 100 and 120? So you see how I could have asked it in terms of percentages or in terms of probabilities. It's essentially the same question either way. If you know what percent of people have an IQ between 100 and 120, then you know the probability that any particular person would have an IQ between 100 and 120. Now notice the background information that we are given here. We're told that we're dealing with something that is normally distributed. So if it wasn't, then we wouldn't be able to use this method. We're told that the mean is 100 and that the standard deviation is 15. So we've got our mu and our sigma. We need that no matter what method we're using. And then the question, the thing they're asking us to find, well, it's the percentage or the probability of scores between 100 and 120. That's represented graphically by the shaded region here under this bell-shaped curve. So we want P of, do you know what goes here inside the parentheses? How you would write that? P of, what about X? Well, P of X being between 100 and 120. And here's how you'd write that. The probability of 100 less than X less than 120. Now, if you're using the table or the z-score method, we'd want to convert these to z-scores. When you convert 100, you just take 100 minus the mean, which is also 100, and divide that by the standard deviation, which is 15, and that comes out to be 0. When you convert 120 to a z-score, you take 120 minus 100 divided by 15, and that comes out to be 1.33 as a z-score. So now we want the probability of z being between 0 and 1.33. So if you're doing this with the table, you would go to table E, and you would look up both of those z-scores. I would start with the bigger one because it comes first in the subtraction. So when you look up where z is 1.33, the table gives you 0.9082. And when you look up where z is 0, 0.00, the table gives you 0.5000. And now to get our final answer, we need to subtract those. 0.9082 minus 0.5000 equals 0.4082. If you want that as a percentage, it would be 40.82%. So 40.82% of all the scores are between 100 and 120, and so that would be the probability of somebody's score being between 100 and 120. What percentage of the scores are between 80 and 120? So here we want P of 80 less than X less than 120. And if we do it by converting to z-scores, the 80 converts into negative 1.33, and we've already seen that 120 converts into positive 1.33. You look those up on the table and subtract what you get, 0.9082 minus 0.0918, and you get your final answer of 0.8164, or 81.64%. What percentage of the scores are above 136? So here we want P of X greater than 136, the percentage or the probability of values of our variable that are greater than or above 136. We could also write it like this. We're talking about being between 136 and infinity. So if you convert the 136 to a z-score, it turns out to be 2.4. So now we want P of z being greater than 2.4. So you look that up on the table, and then you have to subtract what you get from 1. 1 minus the number on the table, 0.9918, gives you 0.0082. So that's less than 1%. It's 0.82% of the scores that are above 136. And what percentage of the scores are above 75? Now we want the probability of X being greater than 75, or the percentage of X's that are greater than 75, that is between 75 and infinity. Converting 75 to a z-score gives you negative 1.67. Here's how that looks on the calculator. Parenthesis 75 minus the mean, which is 100, close parentheses, divided by the standard deviation, which is 15, and that comes up as negative 1.666 and so on. And if I round that to 2 places after the decimal point, to the nearest hundredth, it's negative 1.67. Because what comes next is a 6, this rounds up to a 7. So we want the probability of z being greater than negative 1.67. Look that up on the table, and you get 0.0475, and then we need to subtract that from 1 because we want the probability of z being greater than that. So 1 minus 0.0475 is 0.9525. As a percent, that would be 95.25%. Next example, stolen from the book. The average number of calories in a 1.5 ounce chocolate bar is 225. Suppose that the distribution of calories is approximately normal, with sigma equal to 10. Find the probability that a randomly selected chocolate bar will have, and then it's a three-parter. Part A, find the probability that it will have between 200 and 220 calories. Then part B, find the probability that it will have less than 200 calories. Part C, find the probability that it will have more than 230 calories. So part A, in that probability notation, we're trying to find the probability of X being between 200 and 220. Now this time I'll do it using the calculator method. I'll get my graphing calculator, and I will ask it for normal CDF from 200 for the lower number to 220 for the upper number, with a mean of 225 and a standard deviation of 10. And the answer is 0.3023. For the second question, we need the probability of X being less than 200. And then the third would be the probability of X being more than 230. So when I do the second one, I put it in as normal CDF, and less than 200 is really from negative infinity to 200. So I would put that in as from like negative 9999 to 200, with a mean of 225 and a standard deviation of 10, and the answer comes out to be 0.0062. So that's the answer to that one. And then the answer to part C, normal CDF, more than 230 would be starting at 230 and going up to really infinity, but I'm going to just put in a really big number like 9999 or 99999. The mean is still 225. The standard deviation is still 10. and we get an answer of about 0.3085. Now we still have another kind of problem to talk about, so I will come back in another video and we'll look at how to do the second kind of problem, which is kind of the reverse of what we have been doing.